Okay, so this half of the unit, or this half of the packet, excuse me, we're going to focus on graphing all of the trigonometric functions. Sine and cosine, you're going to graph extensively. The other four functions, we're going to develop the graphs today, but then you will have to recognize them and be able to either match their names with the graphs or the graphs with their names, back and forth. So let's start on page 42. We're going to graph the sine function, and we have this table here. So I'm going to draw my quadrantals. And then I'm going to pick a radius of 1. So this spot would be over 0. No, it would not. It would be over 1, up 0. Here would be over 0, up 1, negative 1, 0, 0, negative 1. And we know that sine from our circle here is y over r. So anything over 1 will be that y coordinate. So at 0, the sine value is 0. At pi over 2, the sine value is 1. At pi, it's 0. 3 pi over 2, negative 1. 2 pi, 0. And then negative pi over 2, so we'll go this way. Negative 1. Negative pi. Negative 3 pi over 2. And negative 2 pi back at the beginning. So now I'm going to take these values, and my x scale is my radians, my y scale is the outcome, that ratio of sine. So we got 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, 2 pi 0. Let's connect those dots before we go to the negative side. When you connect your curve, it's a nice smooth wave, not V's, just nice smooth wave. So now we're going negative pi over 2, negative 1, negative pi 0, negative 3 pi over 2, 1, and 0. Again, a nice smooth wave. And the graph continues on this way and continues down this way with arrows, because no matter how many times you would go around and around and around the circle, I could keep graphing those different angles on my x-axis. And now we have these properties of our trig functions. So the amplitude is the distance from the middle to the top. You could also say the amplitude, if we go from the maximum to the minimum, it's half that total height. So this amplitude is half the total height. So in this case, from the middle, which is 0, to the top, that is a length of 1. If I go to the bottom part, the length from the middle to the bottom is 1, because that length is 1. Period is one rotation of the pattern, or one rotation around the circle. So if I see here, we go middle, maximum, middle, minimum, middle. That's one full wave, one full rotation. So from the start to the end of the rotation is the period, that length here, and that length is 2 pi. Domain, just like in our very first unit or from your prior math classes, domain is your x values. And in this case, it's our angles. And because we can go around and negative around, the domain is all real numbers, or we can write it as negative infinity to infinity. And the range is the y values. So we have a minimum of negative 1, a maximum of 1. So that's negative 1 to 1. Or you can write it this way. And these are the square brackets because we equal at negative 1 and 1. Okay, so we're going to do that all again for cosine. You know what? You can, so since we drew these up here, I'm just going to copy them to the bottom. You can keep looking at your paper because you can look at the whole page where I cannot. Okay, but now cosine is not y over r. Cosine is x over r. So the same as with the sine function, cosine being this x coordinate over the radius. So at 0, that's 1. Pi over 2 at 0. Pi, that's -1. 0, 1. Let's go backwards. So at negative pi over 2 is 0. Negative pi, pi over 2, and 2 pi. Let's plot those. 0, 1. Pi over 2, 0. Pi -1. 3 pi over 2, 0. 2 pi 1. Put my negative points on here. And because it's the same wave shape as sine, at the ends, we're not going to continue up. It's that curve that turns back around. So either you have to stop directly at your point, or you can turn it around a little bit. I'm going to put my arrow there. This way. Make a nice smooth curve. So amplitude again is either half the total length, half the total height of the waves, or from the middle to the top, which is still a length of 1. That's the amplitude. Period is 1 full rotation. So if we go maximum, back to maximum, that starts at 0 and ends at 2 pi. So that's a length of 2 pi. Domain is all real numbers again, because we can have x that goes on forever and ever, any angles around and around and around. And then range, the lowest is -1 up to +1. Okay, so if you turn now to page 43, we've got the tangent function. Let's sketch our quadrantals again. Okay, so tangent around our circle was the ratio of y over x. So at 0, that's 0 over 1 is 0. At pi over 2, 1 over 0, that's undefined. At pi, at 0 over -1 is 0. 3 pi over 2, -1 over 0, undefined. And 2 pi, we're back at 0. So now let's go the negative direction. Negative pi over 2 down here is undefined. Negative pi is 0. Back up at -3 pi over 2, undefined, and 0. So that means at every pi over 2, we have an asymptote. So draw these dashed asymptotes here. And now if I put all these other points in at 0, I really don't have enough to make the rest of the graph. So let's think about one other nice angle for tangent. if we think about pi over 4 with that special right triangle, what does tangent of pi over 4 equal? That's 1. So here at pi over 4, I have a y value of 1. But now what about down here at negative pi over 4? That's going to be this y over x, so that's negative 1. And so if we take that pattern and continue it on, to the right of that x-intercept is at positive 1, to the left of the x-intercept is at negative 1, to the left is at negative 1, to the right of the x-intercept is at positive 1, to the left is at negative 1, one more. And so when we connect our points, we get a piece of the curve up and a piece of the curve down. So we get this kind of x cubed type shape that repeats. I find it easier to go from the x-intercept down, and you have to approach your asymptotes. Oh, I missed that point. So you approach the asymptotes from both sides of your x-intercept. So because there's no maximum or minimum, there is no amplitude. There's no height. You can't measure the height. For the period, we want to know how often does this repeat. This length from negative pi over 2 to pi over 2, that's between those asymptotes, is one full pattern of this curve. So from here to here is the period. And that length would be pi, because we got half pi and another half pi. So together that's pi. Domain, I'm going to come back to that one. It's a little trickier. The range now, because we go up forever and down forever, is all real numbers. So here's how we're going to do domain. These vertical asymptotes will keep repeating at every pi over 2. So this was 1 pi over 2, 3 pi over 2. The next one would be 5 pi over 2. So here's how we can write that. The domain is all real numbers, but x cannot be pi over 2, because that's this first one. Plus, they repeat every pi, but it's every multiple of pi. So if I'm here, this is 1 pi away. Then it's another 2 pi away, because it's 1 pi plus another pi. And we're going to say where k is an integer. Because an integer is a positive or negative whole number. So I can go minus a pi, minus another pi, minus another pi this way, and we can keep going every pi, multiples of pi, to the next asymptote. So that means our asymptotes are when x equals pi over 2 plus pi k, where k is an integer. Okay, so now we've got the 3 reciprocal functions. Pause the video and take a look back. What did we fill in here for our sine value? Oh, wait, well, except for the pi over 6 ones. Let's go fill in your quadrantals at 0, pi over 2, and so on. And let's do sine of pi over 6. These special right triangles are always going to keep coming up. You cannot avoid them. So sine of pi over 6 is 1/2. So cosecant is the reciprocal of sine. So I'm going to reciprocal all these values. And remember, this 0 came from 0 over the radius. 1 over the radius, like that. So the reciprocal of 0 is 1 over 0. That's undefined. We're going to have some more asymptotes. Reciprocal of a half is 2 over 1. Reciprocal of 1 is 1. So keep going down the chart here. Now let's plot those points. So we have a vertical asymptote at 0, at pi, at 2 pi, negative pi, negative 2 pi. All right, so at pi over 6, that's 1/6. That's kind of here. That's up here at 2. Pi over 2 is 1. 3 pi over 2 is negative 1. Negative pi over 2 is negative 1. Negative 3 pi over 2, positive 1. And I don't want you to draw this. I just want you to watch for a minute. If I sketch the sine function, I want you to see what happens. So there's our sine function. If I take this curve and flip it out, here's that 1/2 that became 2. So here's another 1/2 that becomes 2. And we get these parabola, these U-shaped curves that build off the sine function and approach your asymptotes this way. So go ahead and draw in what I did here in blue. That is the cosecant function graph. And I can build it off of the sine graph since they're reciprocals. Okay, again, there's no amplitude because there's no height when you have these graphs going up and down forever. The period is the same as sine. It's 2 pi because a pattern of an up shape and a down shape is one rotation or one period. Domain, we're going to write similar to the way we did tangent. It's all real numbers, but x cannot be. So here's the first asymptote at 0. And these asymptotes still repeat every pi unit. So we're going to go plus pi k, where k is an integer. So the asymptotes are x equals 0 plus pi k, where k is an integer. And now the range, there's nothing in between here. The range, it starts at 1 and goes up, and starts at -1 and goes down. So the two different ways we can write that is we can say -infinity to -1 and 1 to infinity. That's starting down here at -infinity, going up to -1. Skip over all of this, start at 1 and go up to infinity. Or we can say y is less than or equal to -1 and y is greater than or equal to +1. Okay, so we're going to do the same thing for secant and cotangent. Okay, so for the secant function, which is the reciprocal of cosine, let me fill in my cosine values again. So you can go copy these back down from page 42 where we first did the cosine function. Now pi over 3, which is 60 degrees. Let's see, that's 1, 2, √3. Cosine is a half. So again, when we reciprocal everything, that's 1, that's 2 over 1. Undefined, -1, undefined, 1. So I'm going to dash my cosine function again, kind of like I did sine. So that was 0, like this. So I'm going to picture this cosine function. And you can dash that on yours if you'd like. Because then anywhere that cosine was 0, the reciprocal would be undefined. So I know all these x-intercepts on cosine are the asymptotes for secant. And then instead of being this curve down, I know it's going to curve up towards the asymptotes. And from the minimum, curve down towards the asymptotes. And there is our secant graph. No amplitude, there's no height. The period is the same as cosine, which is 2 pi. I'll highlight a period for you. So we got here as part of the pattern, here, and here. That's 1 period of cosine. I'm sorry, and 1 period of secant, because secant's what we're focusing on. The domain, we're going to go with all reals. X cannot be, and I'll pick this first asymptote to start, can't be pi over 2 plus. How long in between the asymptotes is pi. We need multiples of pi, so we'll go pi k, where k is an integer. That means my asymptotes are x equals pi over 2 plus pi k, where k is an integer. And then the range, we've got negative infinity to negative 1. That's down here up to negative 1. And 1 to infinity. We skip all this, start at 1, and go up to infinity. If you like the less than and greater than better, that's y less than or equal to negative 1, y greater than or equal to 1. Okay, last but certainly not least, we've got cotangent, which is the reciprocal of tangent. So let's answer this question first. We haven't really focused on this, but way back on the very first pages, instead of having tangent as y over x, it's printed that tangent is sine over cosine. Because this is y over r, x over r, so it simplifies to y over x. So that means cotangent is cosine over sine. We got that question answered there. All right, so for our tangent function, we're going to go back and look at what values we put. This was 0, this was undefined. Because here we did 0 over 1, and this was 1 over 0. And it kept going like that for our whole chart. So if we reciprocal all these, 0 over 1 becomes undefined, and 1 over 0, when you flip it, is 0 over 1, so that's 0. So all of these zeros become undefined, and all undefineds become zeros. So we've got an asymptote at 0. Whoa, that's crooked. An asymptote at pi, 2 pi, negative pi, negative 2 pi, and then all these zeros here, 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 and here. And again, that's not much to graph by. So let's think about pi over 4 again. What is cotangent of pi over 4? So cotangent of 45 is 1 over 1. That's 1. So here at pi over 4, I can go 1. let's see, this is pi over 4. Pi over 2 is 2 pi over 4. So let's figure out 3 pi over 4, which is here. So what is cotangent of 3 pi over 4? That's negative 1 over 1. So we get that point. And now in a similar shape, but decreasing, well, third time's a charm. Let me see if I can hit that point. There we go. And come down. So similar to the tangent shape went like this through the origin. So cotangent, it's reflected, it's going to go this way. Approach your asymptotes. No amplitude. The period will be the same as the tangent period. So between these asymptotes, this one pattern is from 0 to pi. So that's a length of pi. Domain is all reals, but x can't be. So let's start with our first asymptote here at 0. So it can't be 0 plus another pi k, where k is an integer. And then that means the asymptote is x equals 0 plus pi k. K is an integer. And the range is all real numbers because we go down forever and up forever. So if you flip through the next few pages, they're a summary of everything we just graphed. It's kind of nice to have a printed summary there, like if you had a textbook for our class. And now your homework is page 48. I want you to graph at least one period for each of the functions, labeling your x and y values clearly. So for sine, I know the period's 2 pi. And then we had pi, pi over 2, and 3 pi over 2. We had all of these quadrantals. If you wanted, for some of the ones with the asymptotes, you could go back to negative pi over 2. But you don't have to do this from your memory. You can look back at what we graphed in class, access the video again, and graph one period, meaning one rotation of all 6 graphs.